Okay guys, this video covers theoretical versus practical domain. As we know, domain are the set of input values that go into a function. The set of input values or the set of x values. So we want to distinguish between a theoretical domain and a practical domain. Theoretical is kind of what it sounds like. They're the values that in theory would make sense. So the definition we're going to use is that they are the values of x that make mathematical sense. Hey. So we want to just remember that there's really two rules that we can't break mathematically. The first one is we can't divide by 0. And then the second rule we can't break is we can't take the square root of a negative number. Other than that, we can do pretty much anything and put any number in for x. Our practical domain, however, is when we're given a specific scenario, so a word problem, they are going to be the values of x that make sense in a specific scenario. So this is really going to be dependent on the given scenario. So here, we've got a few word problems that we're going to look at. Your parents pay $4 per chore you do around the house. You also get a weekly allowance of $10. Write a function that shows how much money you have, m, if you do c number of chores. So the independent variable is what I control. So I remember that IV is what I control. So in this scenario, I control how many chores I do. And just a reminder, you may remember this from science, but the independent variable is the x value. And then the dependent depends on the independent. So how much money you earn is going to depend on how much you do for chores. And then this is always the y variable. So when we go to write our function, we always write it as a function of dependent of independent, meaning we're going to write m of c. So normally when we write f of x, f is the dependent variable and x is the independent variable. So the function is m of c equals, you start with $10 no matter what, and you gain $4 for every chore. So 10 plus 4c. So theoretically, what values of c could be put into this function? Well, we ask ourselves, are we dividing by 0 anywhere? No. Are there any square roots? No. So theoretically, our domain is that c, because that's our variable, not x, can be any number. So this symbol basically is just is in mathematics. And then this symbol, remember, means all real numbers. So that statement says c can be any number. The practical domain are the values of d, or of c rather, that make sense in this given scenario. So can you do any negative chores? No. So the least number of chores you could do would be 0. So c has to be a number between 0 and, let's just say the most you can do for chores in one day, because there's like a realistic limit. Let's just say it's 4. So if you can do 4 chores in a week, then you would have 28 as the most chores you could do. So this is assuming the most you can do is for a day. So sometimes this larger number, we kind of just like make a guess as to what the higher limit could be. All right, so in this next case, you have 50 pieces of candy to split amongst your friends. The function below is going to represent the amount of candy each friend gets, C, if you have F friends. So in this case, what I can control is how many friends I decide to give my candy to. And then how much candy they get is going to depend on how many friends there are. So my function should be C of F. And the way I'm going to decide how much candy each friend gets is I'm going to take how much I have and divide it by how many friends I'm sharing it with. So theoretically, what numbers can go in for F? Well, am I going to be breaking any of my math rules? If I'm going to break any of these rules, then I have to exclude that value of F. So if F was 0, I would end up dividing by 0. So F can be anything. We're going to use the same statement as before. F can be anything, except this time, F cannot be 0. When F is 0, we end up dividing by 0, which is not okay. And then for my practical domain, it won't make sense to have 0 friends. So I am going to have 0 be my lowest value, but I'm not going to have it be equal to. Or another way maybe we could write this is that we have to have at least one friend to share the candy with, because it won't make sense to not share it with anybody. And then the most I can have is 50. After 50 friends, people would be getting half of a piece of candy, and that really wouldn't make sense in this scenario. So that's my practical domain. That's what makes sense in this specific problem. We're going to do one more problem on the next page. The other two we're going to come back to later in this unit. So in this case, the independent variable is the seconds that you're on the escalator. Time typically is the independent variable in these types of problems. And then your height depends on how long you're on the escalator for, so that's the dependent variable. So my function is going to be h of s equals, I start at 60 feet, and then I decrease by 0.87 feet per second. So theoretically, I'm not breaking any of those math rules. There's no division, there's no roots. So S can be any number theoretically. But in practicality, there's no such thing as negative time. So I'm going to start my domain at 0. And then the furthest I can go on this elevator or escalator is until I get on the ground. So if I do 60 divided by 0.87, that's going to tell me how long it's going to take me to get onto the ground. I'm basically doing d divided by speed. My distance divided by my speed is going to give me the time on the escalator. And that gives me roughly 69. So the longest I can be on this escalator for is 69 seconds. After 69 seconds, I'm on the ground, so it won't make sense to have this function exist any longer. So the last thing I want to do is just take a look at some theoretical domains. It doesn't make sense to do a practical domain on this page because there are no scenarios. Since there are no scenarios, I'm not going to do practical domain here. I'm just going to look and see if any of my rules are being violated. So for this first function, the rule that's being violated is that I can't take the square root of a negative. So I need to make sure that my domain are x values that are greater than or equal to 0. If x is -1, I'll be taking the square root of a negative, which is a mathematical no-no. For this next one, x can be anything as long as it's not 0, because as soon as x is 0, I'm dividing by 0, which is not allowed. So my domain is that x can be any number except for 0. For this next one, I want what's underneath the square root to be greater than or equal to 0. So I'm going to start off by making this an equality. I want v plus 5 to be greater than or equal to 0, because as soon as it's not, it's going to be less than 0, which is a negative. So if I solve this, I get that my domain has to be v greater than or equal to negative 5. Anything less than negative 5 is going to cause me to take the square root of a negative. Here, I can't divide by 0. When 2x minus 1 is equal to 0, I'm going to be dividing by 0. So I need 2x minus 1 to not equal 0. So if I add 1, and if I divide by 2, I get that x cannot equal a half. So x can be anything as long as it's not a half, because if it's a half, then I'm going to be dividing by 0. For this next one, the 4 that's outside of the square root doesn't really matter. It's this part that I'm interested in. So 3r plus 5 has to be greater than or equal to 0. So if I solve that, I get that r is greater than or equal to negative 5/3. As long as r is bigger than that number, we won't be taking the square root of a negative. For this next one, this has to be not equal to 0. So 4 times 5x minus 2 cannot equal 0. And if I solve that, I get that x can be anything. So it can be all real numbers. It just can't be 2/5. So for these last two, cube root, I can take the cube root of any number. It's okay if it's negative or positive. So for this one, x can be literally anything. There's no restrictions. For this one, however, you can't take any even roots of a negative, so we need, for the inside of this one, to stay positive. And so if I solve that, I get that x has to be greater than or equal to 0. Because if it's less than that, I'm going to be taking the even root of a negative, which is not allowed.